dividing polynomials, something you've never done before, and I am just encouraging you guys right now to be really, really careful. This is not a hard process, but if you are losing track of space holders or forgetting positives and negatives, it will screw everything up. So just work slowly and pay attention to detail. So first of all, I have an example of long division. I heard some of you saying a minute ago, I don't remember how to do long division. You know what? When I had to put this together for you guys, I was like, oh man, I have to recall how to long divide too, because it's been a really, really long time for me too. So anyway, to long divide, this is what we do. First of all, this number right out here is called the divisor. You guys remember that word? The divisor? 51 is supposed to be. And this number that's underneath the division sign, that thing is called the dividend. And the first thing that you need to do is decide whether or not, does 51 go into 10? Can you divide 51 into 10? No, it's not. There's not enough.
Interruption. All students with the last name C or D, please report to the auditorium for pictures. Last name C and D, report to the auditorium for pictures. Thank you.
Alright, so 51 does not go into 10. So then you go to the next digit, which means now we're talking about hundreds. Does 51 divide into 109?
Yeah.
Yes, it does. So how many times does 51 divide into 109? Twice. So you put a 2 up here. See the 2? Alright, so we do 2 times 51. I think I need to calibrate this. 2 times 51 is 102. Alright, and now this is the deal. You need to, if you guys remember, you have 109 and 102. What do you do to those two numbers? You subtract them. And that's going to be not as big of a deal for this kind of a problem, but we start talking about polynomials, that's going to be a bigger deal. So we subtract the 2, so 109 minus 102 is 7. Well, now we're looking at the 7. Does 51 divide into 7?
No.
It's not divided into 7, which means then that we need to bring down the 6. So we bring the 6 down, so now what we're doing is taking 51 and dividing it into 76. Does 51 divide into 76? Yes. How many times does it divide into it? 1. So we have a 1 up on top. 1 times 51 is 51. Again, you subtract the 76 and the 51. 6 minus 1 is 5. 7 minus 5 is 2. Does 51 divide into 25? No, it does not. So now you have to bring down the 4. 51 divided into 254. It goes in 4 times, and you guys might need to use your calculators at some point to be able to do that, but it divides in 4 times. 4 times 51 is 204. Again, you subtract these two things, it leaves you with 50. So now we have 51 dividing into 40. Does 51 divide into 40?
That's 50,
Does
not
it-
40.
What did I say, 40?
Yes.
I'm sorry. 51 does it divide into 50?
No.
It does not divide into 50. So, and then there's nothing else to bring down. So what do we call 50? We call it the remainder. So, notice how I have this written. It's a remainder of 50 out of 51. So the remainder is 50. We have the denominator there is 51. So in other words, the divisor is the denominator of the remainder. And that's going to show up in these kinds of problems too. So, did it come back to you at all?
A little bit.
A little bit? Okay. All right, so, unfortunately. Okay, so now we're going to make it a little bit harder. We're going to take this polynomial x cubed minus 2x squared plus 3x minus 4 and divide it by x minus 2. So, we put the x minus 2 out in front, called the divisor. And then this polynomial underneath the division sign, that is called the dividend. So, we start over here at the left with an x. And we divide x into x cubed. How many times does x divide into x cubed? And what I mean by that is this. You need to take x cubed and divide it by x. Well, what is x cubed divided by x? This is x to the first power. That leaves you with x to the second power. So we have an x squared up here. And then we need to multiply this x squared by x and by negative 2. So x squared times x is x cubed. And then x squared times negative 2 is negative 2x squared. Are you with me there?
Sort of.
So we are taking this x squared right here and we are multiplying it by this x and front by that -2. The difference between what we did over here and what we did here is obviously we're using polynomials now, but this x squared, it's like it has to be distributed into the x and into the 2. So x squared times x is x cubed, x squared times -2 is -2x squared. This is the deal now though. You have to subtract this polynomial. You might want to add this to your notes actually. You have to subtract this from this. So we need to put, I'm going to put that in parentheses and I'm going to put a minus sign out front. So, because this is my concern, is that if you don't do this, when you subtract these, you're going to forget that it changes the signs on both of these things. So when you subtract this polynomial, you are subtracting the x cubed and subtracting the -2x squared. So I change it to I put a minus sign out front, which means this is going to become negative. So what is x cubed minus x cubed? 0. Now we have a -2x squared, and we have to, remember we are going to subtract a -2x squared. Well, when you subtract a negative, what are you actually doing? You're actually adding. So we really have a -2x squared plus a 2x squared. And I'm going to do something to this right here. I'm going to change this minus sign to a plus sign, and then everything after it, I'm going to switch signs. So I'm going to throw a negative in front here, and I'm going to change that minus to a plus. So now maybe it's a little bit easier to see that you have an x cubed minus x cubed. That gets you 0x cubed. And then we have a -2x squared and a positive 2x squared. Those cancel out, giving you nothing again. So we have nothing here. But now what we need to do is bring down the 3x. So now you need to take this x out front, and you need to divide it into 3x. So in other words, you're going to take 3x and divide it by x. The x's cancel out. What are you left with? 3. You're left with 3. So in other words, x times 3 will get you 3x. So I put a 3 up here now. Put a 3 up top. But now when you multiply, you have to do, remember how over here we would take that number and we would multiply it by the divisor? We're going to do the same thing here. 3 times x is 3x, and 3 times -2 is -6. But what I'm going to do is add the parentheses there. I'm going to throw my minus there. You guys know though when you minus and you distribute the minus sign in, it's actually like having a plus sign here with a minus sign here and a plus sign here. So the 3x and the -3x, they cancel out. What do you have here? You have a 6. You know what? I screwed this up in my notes. So if you guys could add this. See this -4 right here?
Yeah.
That should have been brought down. That -4 should have been brought down. -4 plus 6 is what?
2.
Is 2. So 2 is left over. That we don't have anything else to divide into that thing. So 2 is called our remainder. So our remainder is 2 over the divisor. Remember the divisor is always the denominator. So it's 2 over x minus 2. And that's our, what is it called when we get our answer? What is this thing? What's the answer to a division problem? The quotient. Yes. Yes, Marcus.
How come you don't use the -2 stuff?
You know that's a good question. I don't know why it works like that. Especially in this case, it's a constant number, so I don't know. I don't have a good answer for you. That's just the process. You start with just the x, divide it into that, and then it just kind of falls into place. Sorry, that's a horrible answer, but okay.
So if you multiply the quotient times the divisor, whatever you should do.
Yes. If you take this quotient and multiply it by the divisor, you should get the
How would you
Which one better?
like? How would you multiply it again with the remainder?
Well, this right here would end up being x, here, let me see, that would end up being x squared plus 3 plus 2 over x minus 2, and then you would have to multiply that by x minus 2.
So you just had the remainder out of it.
Yep, you take, so that's like having 2 extra out of this total. And then you would have to distribute. And then this right here would end up, see, when we multiply this x minus 2 by this part right here, they would end up canceling each other out. This would not be a fun thing to multiply, so remainders in this case would not be fun. We certainly could try one, but,
I'm good.
are you sure?
Here comes the brain.
We'll try one individually if you want to. Alright, let's do x cubed minus 1 divided by x minus 1. Alright, I'm showing you this example. Why am I showing you this example? I should ask you that. Why do I have this example up here?
It's got zero.
Yes, to torture you and because there are zeros in it. Do you see how I had to add some zeros in here?
Yeah.
Those are like placeholders. Details, 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 details. It keeps your work clean and organized. I highly encourage you. Could you do this without? Yes, you could, but I think this is very, very helpful to have the placeholders in there. Yes,
Are you allowed to do that?
allowed to do what?
It's a zero.
Yeah, you can add, yeah.
She
this
said
is
that.
I'm adding nothing. I'm adding 0 x squared. Okay, you guys, stop.
It doesn't seem like it's a legal move.
But I feel like that should be a 1
What should be a 1?
in front of an X. There's always like a 1X instead of like,
Well, if you have an x, then you have an x. If I just write x, that means I have one of them.
yeah, but that means
But I don't
you
have
zero.
I don't have any x's here, so I have
Oh,
to have
okay, I
0
get it now.
x's of them.
Okay, I didn't understand.
Alright, so we have x minus 1, the divisor out front. This right here is the dividend, but it's missing. We have an x cubed, we don't have any squares, we don't have any x's, and then we have a constant at the end. So I added zeros as placeholders here. I'm going to do it the same way. Here's my x. I'm going to divide it into x cubed. So x times what is x cubed? Well, it's x squared. In other words, I'm taking x cubed and dividing it by x. X cubed divided by x is x squared. So I have an x squared up here, so we do x squared times x. X squared times x is, hey, do you see my error, you guys?
Yeah.
This should have been an x cubed. Change that in your notes, I screwed that up. X squared times x is x cubed. And then we do x squared times negative 1. X squared times negative 1 is negative, and I put my 1 here, my 1x squared. I'm going to put this in parentheses again, and I am going to subtract it, which really means that I am adding the opposite of this and the opposite of this. So the x cubes, they cancel out. We have a 0x squared and a positive 1x squared. What does that get me?
1X?
Gets me a 1x squared.
Yeah, that.
Yep, so we have 1x squared. Now I need to bring down the next term, which happens to be 0 x's.
Yeah.
So now we're going to do x, this x right up front again, times what gets me x squared. So in other words, I'm taking x squared, dividing it by x. What am I left with? Left with just x. So I put an x up here, a positive x. So now we do x times x is x squared, this x squared right here, and then we do x times negative 1, negative 1x. Put parentheses around it. We're going to subtract that entire polynomial, which really means we are adding the opposite and the opposite. The x squareds cancel out. We have a 0x and a 1x giving me 1x. Now you bring the minus 1 down. So we have x times what will get me 1x. In other words, how many times can I divide that x into 1x? 1 time. So I put a 1 up here. But now I need to take that 1 and I need to multiply it by both the x and the minus 1. So 1 times x is x. 1 times negative 1 is negative 1. I am subtracting that polynomial, which really means I am adding the opposite and the opposite. So we have a 1x and a minus x, they cancel out. A negative 1 and a positive 1 give you which means we have no remainder, so I have nothing left at the end. If we did have a remainder, it would be the remainder divided by x minus 1. Yes?
How do you do this without the zeros?
Very easy way.
I could go through it with you individually if I could even do it. When I do these things, I always include the zeros. Because it gets too confusing. You lose places, you lose, especially because when we are, with our quotient ends up having an x squared and an x in it. And so without having those places there, you lose things. Okay? I can try it with you later, but I'm not gonna do it up here. Alright. Here's the problem. This polynomial divided by this one. This is our divisor. I put it out front. Here's our dividend. I put it right here. This is not in your notes, so please make sure that you are following along. Alright, we start with x squared. This x squared right here. We need to divide that into, don't worry about these two terms. We just have x squared and we're going to divide it into 2x to the 4th power. X squared times what will get me 2x to the 4th power? In other words, and I know some of you don't need to hear me say this, but 2x to the 4th divided by x squared. Well, that's going to get me 2. And then we have an x to the 4th and an x squared, making it x squared. The 4 and the 2 give me a quotient of x squared. All right, so we have 2x squared that has to be multiplied by both x squared, by 2x, and by -3. You with me?
Yeah.
So what is 2x squared times x squared?
2x to the 4th.
2x to the 4th power. 2x squared times 2x, what is that? 4x to the 3rd power. And then 2x squared times -3 is -6x squared. Yes? I'm going to throw parentheses around it. I know I need to subtract, so I'm going to put a minus sign here. But now what I'm going to, if you don't need to do this, don't do it, but I think it's helpful. I'm going to change the minus to a plus. I'm going to throw a negative in there. I'm going to change that minus, or that plus to a minus, and that minus to a plus. Those cancel out. What about these?
Cancel.
These cancel out, very nice. And then we have a negative 5x squared and a positive 6x squared. What's a negative 5 plus 6?
X squared.
X squared, or 1x squared. So I'm just going to put an x squared down. Now, this part sometimes gets a little bit confusing because you don't know. What do I bring down? Do I bring down just the 3x or do I bring down the -2? Well, you know what? Whenever in doubt, just bring one down. And then if you need the other one, you're going to have to bring it down too. And I think in this case, we are going to need to bring both down. But I'm going to start with just the 3x. So I'm going to bring the 3x down. So we have a plus 3x. So now we have x squared that needs to be divided into x squared. How many times does x squared go into x squared?
One.
Yes, once. Okay. So we have a plus 1. So we have 1 that has to be multiplied by x squared. That's x squared. You with me? And then we do 1 times 2x. That is 2x. And then we do 1 times -3. That is -3. There's nothing above it. What does that mean to you? You gotta bring the -2 down. Alright, parentheses around this. We are going to subtract this, which means I'm going to change the minus to a plus. I'm going to put a negative out front. I'm going to change that plus to a minus, and that minus to a plus, and I'm going to add them together. So we have an x squared and a minus x squared, they cancel out. We have a positive 3x and a minus 2x, that is x. And then we have a -2 and a positive 3, that is plus 1. Are we done?
Yeah. No.
Will you check? Can x squared be divided into x? No, there's not enough x's. So what is this called? A remainder. So we have a plus x minus 1 divided by that thing. X squared
I was positive.
plus 2x minus 3. Sorry, it's a plus 1, not a minus 1. Thank you. Okay. X squared plus 2x minus 3. That's our quotient. Yes.
So, all the stuff in the last